Find the solution set of the following linear inequations graphically. Okay, let us begin. We'll start with the first inequation, 3x plus 4y greater than or equals to 12, and convert it into an equation. That means all we have to do is replace the inequality symbol greater than or equals to with an equal symbol, such that we get the equation 3x plus 4y equals to 12. Now, what we can do, we are going to consider two solutions for this particular equation. So let's say when x equals to 0, so if we choose x to be equals to 0, then we can find out the corresponding y value. Then y is going to be equals to 3. Next, if we choose y to be equals to 0, then we get x, the corresponding x value, that will be equals to 4. That means here we have one point with coordinates 0, 3, which is going to satisfy the linear equation, and we have another point 4, 0, which also satisfies the given linear equation. Now what we'll do, we're going to plot these 2 points on an xy plane and join these 2 points to get the graph of the equation 3x plus 4y equals to 12. Now we can observe here that the line 3x plus 4y equals to 12 divides the xy plane into 2 parts. One part, or the one region, is going to be above the line and the other region is going to be below the line. Now in order to check which particular region satisfies the given inequality, we're going to consider a point on the xy plane, and the best point to choose will be the origin, which is 0, 0. So let's choose the origin. So at the origin 0, 0, our inequality is going to become 3 times 0 plus 4 times 0 greater than or equals to 12. That means we're getting something as 0 greater than or equals to 12, and we know that's an incorrect statement. 0 cannot be greater than 12, and that tells us that the point O, or the origin, is not going to be a solution to the given inequation. Or we can say that any point that we pick up from the region below the line is not going to be a part of the solution. So that means we can only choose the region that is above the line. So any point that we pick up from this region is going to satisfy the linear inequality. Coming to the second one, so here we have x greater than or equals to 0. So if we consider the line x equals to 0, this is simply going to be the y-axis. This is a y-axis. So that means we have a line that is coinciding with the y-axis, and we have to consider all the values of x which is greater than 0. In other words, we can only consider the solution that belongs to the region that is to the right of the y-axis. Coming to the next one, we have y greater than or equals to 1. We are going to convert it to the equation, to an equation, to get y equals to 1. And what is y equals to 1? This simply means that we have a straight line which is going to pass through the point y equals to 1, and it's going to be parallel to the x-axis. Now the inequality y greater than or equals to 1 tells us that we have to consider the region which is above the line y equals to 1, because any point that we pick up from this particular region is going to satisfy the equation. For instance, let's say if we pick up this point which is, let's call it -4, +2. So here we have y coordinate corresponding to 2. So if we replace this y with 2, we have 2 greater than or equals to 1. So definitely 2 is greater than 1, so it satisfies the inequation. Now we have to find out a region which satisfies all the 3 regions. Now we can observe here the common region is going to be this shaded region, which is shaded with blue color. So this is the region which satisfies the condition that it's going to lie above the line 3x plus 4y equals to 12. It's going to be it's going to lie to the right of the y-axis. That means x is going to be greater than 0, and also it's going to lie above the line y equals to line. So this is going to be the solution set of the following linear inequations, of the 3 linear inequations. However, we see that this is going to give us an unbounded solution. The solution is going to be unbounded. That means it can have infinite solutions.